In 10.2, we're looking at our exponent rules again. So the first rule that we learned for exponent rules is that when you are multiplying bases, remember bases are the regular numbers like x and 3 in these first two problems. When you're multiplying the bases, you need to add the exponents together. So the first problem, I have x to the fifth times x to the, if there's not an exponent, remember there's an invisible 1. So x to the fifth times x to the first, the rule is to add the exponents. 5 plus 1 would give you x to the sixth. In the second example, we have the base of 3, so we're multiplying the bases. 3 times 3, and so that would combine just to give us 3. And the rule is, again, to add the exponents. So 2 plus 7 would give you 9. So this simplifies to 3 to the 9th power. So the second rule is if you have powers of powers, or sometimes I call them stacked exponents, you need to multiply the exponents. So you kind of distribute into the parentheses and you multiply the two numbers. So our base is 9, that's going to carry over. And we're distributing in and multiplying 6 times 2. So 6 times 2 would leave you with 12. So the answer to this problem is 9 to the 12th power. For the second example, we have x to the first to the third power. So again, we're distributing in and we're multiplying the exponents together. So this would give you x to the third power. 3 times 1 is 3. Our third and last exponent rule that we're going to talk about today is when you divide the bases, you have to subtract the exponents. So again, the bases are 6. So we're subtracting the exponents. So we have 6 to the fifth power divided by 6 to the, again, there's not an exponent, so it's an invisible 1. So we're subtracting 5 minus 1 to give us 6 to the fourth power. And lastly, we have our bases of x. So we have 10, again, we're subtracting the exponents, so the 10 minus the 2 would leave you with 8.